Hi, welcome to the solution video for question 1 through 3 for AP Statistics. We're going to go over all 3 questions in this one video, and I congratulate you for going on this journey as you prepare for a lot more multiple choice questions. So let's take a look. Question number 1, 2, and 3 look like this. So your paper should look about like that. And in question number 1, go ahead and read along with me. The average test score for one class has 30 students, and that score is 75.6. So we don't know exactly what each student got. We know there's 30 students, and that if we averaged everything together, it was 75.6. But what we do know is if I presume they all got exactly the same score, all 30 students, if they got the same score of 75.6, would have an average of 75.6. So on my paper, I'm going to multiply 30 times 75.6, because that would be the total score of all of those 30 students. And again, I could divide by 30, and you'd notice I'd get an average of 75.6. Now, another class of 24 students got an average score of 68.4. So kind of using that same logic, if all 24 kids got exactly the same score, they would get exactly that number, all of them. And probably that's not what happened, but I do know what all of their total scores equal, because I can take the student number, multiply by the score that they got. Then it says overall for the total of 54 students, what did they get as an average? So it looks like I'm taking an average of the averages. There it is. So in a way, if I wanted a formula, it'd have been x bar times n1 plus x bar times n2 all over n1 plus n2. That's basically what I took. If you crunch the numbers there, I end up getting an average score of 72.4. So my answer there would be C. Question number 2. It says variable x has a normal distribution with a mean of 50. So the minute I see a question like that, I'm going to make a normal curve. Nice little bell curve. Down the middle, they told me, should be 50. That's my x bar. The standard deviation, they didn't tell me. So I'm going to call that S sub x. And I'm going to put a question mark because I don't know what that is. So now I say to myself, what do they tell me? Well, they've told me that the standard deviation would be a number so that it would make sure that 80% of the values are within 12 of the mean. So technically what they're saying, and again with my picture, is that 80% falls between here and that those values are within 12. So I just do 50 plus 12 would be 62. 50 minus 12 would be 38. So the part I do know is that 80% of the information falls within this range. So I do have a way, a couple different ways to solve this problem. I know that if 80% are between there, then that just means 40 is to the left and 40% is to the right of the mean. I also know if it's normal, the whole area under the curve would be 100%. So that means 10% has to be to the left and 10% has to be at the right. Now I actually have more information to solve the problem, because now using my picture, I've basically concluded, excuse me, I gotta fix my picture. I've concluded that 62 happens to be the 90th percentile. So 62 is the 90th percentile because the area under the curve to the left is 90% of the data. So that's pretty handy. When I look up on table A, and I look for the area of 0.90, I end up getting a z-score of 1.28. So I can use a fancy calculator, or I can just do it by hand. So the z-score would be, I tell students, A minus P over S for AP statistics. The actual value minus the predicted over the standard deviation. And that's what we're trying to solve for. So an actual value of 62 minus the predicted, which is my x bar, 50, over the standard deviation S sub x. That's what I'm solving for. And again, using the table, I figured out that the area under the curve is 90, gives me a z-score of 1.28. So I can now substitute 1.28 should equal 62 minus 50 over S sub x. When I cross multiply to solve, I get the standard deviation of 9.375, so my answer is B. Last question, question 3. Says a simple random sample of 150 students, so I'm going to write n equals 150. And it looks like they're performing a confidence interval, and it's a proportion. So looking up my formula sheet for a confidence interval about a proportion, and I know that because I see the word proportion there, right? I know that the formula is my statistic plus or minus my critical value times the proportion times 1 minus P over N. So the formula in the formula states the statistic plus or minus the critical value times the standard deviation of the statistic. Okay, that should be pretty easy because I can pretty much eliminate a lot of these right off the bat. I notice that I'm being asked to do a 90% confidence interval. So looking up table B, I notice that a 90% confidence interval for a proportion confidence interval would give me the number 1.645. So if I see the number 1.645, I notice I can eliminate the top two right off the bat. Now, only looking at the bottom three, I say to myself, the statistic is the same, my critical value is the same. Now I just have to figure out the proportion and 1 minus the proportion over N. So I notice N is 150, so it looks like C is my only answer. That's the solution guide for question 1 through 3. Thanks for tuning in.